I'm gonna lie to you. I want you to go back to page 252. Oh, it says it right there. Because I want to talk about what the zero of a function is. Okay? The zero of a function is when we set y equal to 0. And I want us to think about what that means on the graph. Where are we on the graph when y is 0?
The origin.
Not just the origin, anywhere on the x-axis. Okay? So, the zeros of a function graphically give us our y-intercept. X-intercepts. Okay, it's telling us, hey, this is where your parabola hits the x-axis. Or, in a future chapter, in Algebra 2, this is where your graph hits the x-axis. Okay? So, we are briefly going to discuss, hey, how do we find the zeros of a function? Okay, so now we're back to page 254. Page 254, you gotta turn the page. Okay, so if I ever ask you for the zeros of a function, that means you are going to set your equation equal to 0. Okay? We only have a couple different methods to help us out, but they all involve factoring. What do we always look for first when we factor? So if we factor out a GCF, we could factor out a -1, right? And then do you remember that difference of squares pattern we worked so hard on? Can we factor x squared minus 1? Yeah. Remember, a squared minus b squared factors to a minus b, a plus b. Do we have that going on right here? A squared minus b squared. So this would factor to x minus 1, x plus 1. Okay, so what happens when we set x minus 1 equal to 0? There's no like terms to combine. We just got to move the 1 over to the other side. And what do we get? X equals? Okay. If x plus 1 equals 0, then I think that's when we get x is -1. Okay, so what does that mean? That means if we were to graph this parabola, we know that at 1 and -1, it is going to hit the x-axis. We also know, because of this right here, that the vertex is shifted up 1 and it's going to open upside down. Man, that's some great information to know, isn't it? I think the boys got left behind. The boys' track team is still waiting for their bus. You don't need to see Darren. Probably. Okay. What would be helpful in number 6, if I want to find the zeros, can I factor right now?
Yes.
I don't think I can. Well, do we have a GCF to get? What's our GCF? If we take out -4, then left over is x squared minus 4. Well, that's helpful. Okay. X squared minus 4. Is that a difference of squares? X minus 2x plus 2. Jace? Okay, so if I set x minus 1 equal to, excuse me, that's an x minus 2 equal to 0, and x plus 2 equal to 0, then the zeros of our function are 2 and -2. On the x-axis, our parabola crosses at 2 and -2. Yes. Yes. Okay. Now, one more. Number 8. Okay. When I set number 8 equal to 0, why am I setting it equal to 0? What are we finding? The zeros. So we set it equal to 0. Okay, just make sure you have that down. Okay, well, I don't love that this is negative. So let's factor out can I do anything besides -1? Since this is a 1, we can't do it, right? But that's okay. 9x squared minus 1. Is 9x squared a perfect square? Yep. Is 1 a perfect square? Yep. So this is going to factor to 3x minus 1 and 3x plus 1. Okay. Please be careful. I know it's only been a few days since we've had to set factors equal to 0. But when you have coefficients with your x, okay, here we get 3x equals 1, so x equals 1/3. Here we get 3x equals -1, so x equals -1/3. Please be careful with those. I know some of us were a little iffy on our test, so just be careful. Okay, so here's what's going to happen. We have a graded worksheet, but before I give you the graded worksheet, I want to make sure that you can handle finding the zeros of a function. So you are going